be a good sign. Hello, welcome. We are starting Software Engineering 2. Spectacular rainy day turnout, by the way. Don't worry, we're not going to start this one from the beginning. This is what I missed last time. I stopped the testing lecture right prior to talking about security, and I think I stopped it right about here. So I'm going to cover the rest of this lecture. Then we're done with testing, reliability, dependability, all that other stuff. And we're going to move on to software costing. So projecting, costing, and some of the other models are associated with software engineering, which is lecture number 9. So this is the second part of 7. I've already covered 8. So we're going to go 7 part 2 and 9 part 1. So I think we're probably going to get through about half of it today. I believe they already started it. Okay. So a few announcements before we get started. Number 1, sign the roster that's going around. And number 2, next week, we may or may not be in our new building. And that's your definitive answer. That's the answer that I've been told. No, theoretically, we're supposed to be moved over on the 28th, which means classes next week are supposed to be held at the new facility in San Jose. If you don't, is this coffee?
Yeah.
Oh, good. Thank you. If you don't have the address, it's on the website. Downtown San Jose, 2nd Street. No, San Fernando Street. It's on the website. Don't trust me. I don't know where I'm going. But theoretically, classes next week are supposed to be held there. However, they're running a little behind schedule. So I'm supposed to know by the end of the week, there'll be a message that goes out that the TAs will send out to the class with hopefully a confirmation one way or the other. If you don't receive a message, you don't get any notice, call. Because what's going to end up happening, or call or show up or ask your friends or something, or send me an email message. I'll probably know by Sunday if you're checking, because hopefully I'm going to know where I'm going on Monday. So if you can't figure out the information, you can always send me an email message. I can tell you new building, old building. So hopefully you know where to go. But right now, as of now, everyone's saying next week. So we'll see what happens. So I know next week half are going to be over there, half are going to be over here. And it'll be a week before we get all back at the same place at the same time. So I can just kind of see that happening, actually. Also, another little note of caution, the ITU EMS is already configured, hopefully, to accept the midterms and the CSLOs and the assignments for the course. I seriously wouldn't wait until the very last day to start putting stuff in, because here's what's going to happen. Everybody else is going to wait until the very last week. And then the ITU EMS is going to get overloaded. No, there's too much traffic. And they're going to get locked out, and the server's going to go down. So earlier the better, I think, in terms of getting stuff uploaded. Otherwise, then you don't have to run into any of the problems of the heavy use of the server, heavy attacks and stuff. The midterm is due on the 18th. If you are having problems uploading it, you want to send a message to tech support, TECH support at itu.edu. Include your name, your student ID, and the class that you're having a problem with, and a short description of the problem, such as can't post it, get an error message, whatever the error message happens to be. And they're supposed to be helping you. This week it's been kind of rough for them because they've been moving back and forth. So I would believe, hopefully, if we're moved next week, they should be up and running back to normal. So everything should be working out just fine for them. So any other questions, problems, concerns, or anything before I get started? Nope. Good. That's what I like to hear. All right, so let's get back to software engineering. We have the security and software engineering process. This pertains to the development process. We could talk about, you take an entire course on security, actually, in software engineering, and still not cover everything. In terms of what the security goal might be, the security goal is to make sure that the agents, which are the people of the external system, agents, anyone interfacing with the system, who interacts with the computer system, its data, its resources, and anyone who owns the system or has access to the system are the people who are supposed to have access to the system. And they wish to have such interactions. So anyone who wishes the owner of whatever processing of whatever system is the one who defines the security and whether or not access is going to be allowed. So security considerations are part of the entire software development process. It's kind of like testing. You build security now, you build security into the development process. you also want to make sure that the development process is secure. Some of the interesting things that have happened, in fact, the integration of Internet Explorer into Windows caused a serious security issue as an operating system that nobody ever really thought about. So if you think at the end of the project, just like when you save all the testing to the very last day before you're delivering the project, if you save all the security analysis and then security considerations until the very last day, you're going to run into the same problem as you do with testing. So agents and components usually divide everything out in terms of large systems that have components to them, and then when you have agents that are accessing those components. So each has a potential for unreliable or insecure access. It's kind of like the old saying, the weakest link to the system is the people using it. In fact, employees are the company's weakest link, because they're the ones who actually have the interface to the system. So if you're going to have a security issue, it's going to be through somebody who has access versus someone who doesn't have access. It's much easier, especially if you know how to get to the system. So opponents might be acquired from third party, may have unknown security problems associated with them. When you're building software, the interesting thing is nobody ever builds everything themselves. They're using drivers, they're using packages, APIs, stuff that have come from other sources. And usually they're the ones that, not the fact that they're the easiest to blame, but they're also the people that are causing the most security problems as well. Opening up ports, making things available, making things accessible, without thinking about security. Because when you take all these pieces and you put them together, then you realize where the problems are. All you need is one bad link, and your system's not very secure at all. So in terms of the software development challenge, you want to develop secure and reliable components, protect the whole system from security problems in parts of it. So make sure all the parts are working. What you don't want to do is consider security as an afterthought. If you do that, then you add extreme load to the system. It's kind of like what people do when they develop a system and they realize, oh, this is really insecure. We should have password protection. And then they add a front end on top of it. It's a separate module that works with password protection or something, or encryption, or some sort of security mechanism that's added after the software has already been built. So it's not really part of it, but it's working with it. Slows the system down, causes performance issues, may also cause issues associated with reliability, dependability. Especially if the security system fails, the entire system's going to fail. So if you plan security into the development process as part of the process, the likelihood of it becoming a strain on the system, or unneeded burden, essentially, is minimal. In fact, if you integrate it in, you don't create the holes or the weaknesses, so data isn't being transported or saved to a text file without being encrypted or something. So what you don't want to do is use security concepts as an afterthought, because then the entire system is going to be degraded in terms of its performance and its reliability. So we have, in terms of the techniques, we have some barriers. So you place barriers as a concept, as separate parts of the complex system. Isolate the components. Do not connect the computer to the network, maybe, because the barrier would be the computer connected to the network. Firewall barriers, requirements for authentication, perhaps for certain parts of the system. So you basically create a barrier between the protection and the user. So you create a line in which you can have access or don't have access. Each barrier imposes restrictions and permits the uses of the system. And that actually kind of causes as well a burden on the user. Last thing in the world you want to do is make the user go through like 5 password protection screens and authentication. Put your thumb down there, put your retinas, eyes on there, put your password in, and speak. So you can do some voice authentication. And then have a small little hole somewhere else in the system where, if they don't log out, the system stays open when they leave for the day. Which is actually kind of funny because you see that all the time. You see that in computer systems all the time. They don't think about it. They do it to an excess, one technique. And the problem with security, in fact, most of you probably are aware of this already. One, it's like testing the coverage. What are you covering in terms of the security? And also, what technique are you using? Are you using a variety of techniques? Are you doing password authentication? Are you also doing encryption? Or are you also, making sure it's offline instead of an online process, or the database connectivity is on a back-end server instead of on the web server or something? The location of some of these components, the ability to get into the server from a non-application level, from a server level, might also cause a barrier, might cause a problem. So to think you're going to build security into your program, the best security is worthless if somebody has free access to the server or something, if you have one loose link in it. So every barrier imposes restrictions, so the barriers are most effective when the system has been divided out into subsystems if you're going to use the barrier approach. So you have simple boundaries between different components. What you're going to do anyway, if you develop the system in modules, you're going to have different components. And so you can probably think about it in terms of component level configurations. Authentication and authorization, and what I'm going to do is kind of just mention some of these things. It's not a full security course, in fact. This is only about like 10 slides maybe, which is why I skipped it the first time. But I figured I should cover it because it's one of the topics that we're covering. But it doesn't really do modern technology justice. There are so many different technical capabilities and advancements in the area of security. In fact, it's changing even as I'm giving this lecture. So to talk about modern technology really is not going to do you much well outside of basic principles. So in terms of authentication, one of the things that is very common is that whole password issue. In fact, I don't know why people rely so much upon that. But it is basic. Every program has some sort of authentication technique to it, if there's security in it. Even when you log onto your email, you have an email name and a password. And then sometimes the passwords are stored in text on the computer system. So you can just look up the password. Sometimes they're encrypted. Sometimes they're not a password. Sometimes they're 2 keys. What I really like are those RSA keys, where you have a generated key from a token that is basically giving you some calculations, some algorithms running that's creating a random key that you're using with a key that you know, and you're entering them all in together. And it's all synced with the network system, so it knows if you got the right combination. And it only works for like every 2 minutes, and then the code changes. So it's really hard to actually kind of defeat that type of password. But everybody knows password protection is the easiest mechanism to defeat in terms of cracking into something. In fact, you see it on the TV all the time. Oh, what's the password? Oh, this stuff. Try the dog's name. Try the birth date, because everyone picks passwords that are easy to remember. Oh, it's my dog's name and my daughter's age. Okay, there we go. There's the password. And you don't really think about what if someone steals it? Anyway, but there's people that there's password generator programs actually as well that come up with automatic generations of password combinations. The agent possesses a smart card, perhaps the smart card. It's actually what we're going to use to get into the parking over at the new facility. You scan a card, and it says who you are. And then I don't know if you guys are going to get them. I don't even know if I'm going to get one, but we have limited parking that's secured over there. So essentially the concept of the card is it keeps a number, swipe it. If it's a good number, it opens the gate for you, I guess. If it's a bad number, I don't know what it does. But maybe if it's not the right card. You may also have access, well, you might, where does the agent have the access to? Controller, does he have the access to the program, to the interface, which is an interesting question. What are the physical properties of the agent, like fingerprint properties, retina scans from the eyes or something? And then also to look at establishing an authentication agent may also do access control lists and group memberships. So you might take users and attach them to a group and give them control. See this in terms of Oracle databases, network security systems, and all sorts of different things where we can combine people into groups and then say that this group only has access to this drive or to this table, doesn't have access to the whole system. So not only do you have a user password to get in, but you're also attached to a group. And the group has restrictions as well. So you can kind of set different levels of access control. Here's an example here of an access model for digital content where you have a user who's assigned a role, who has abiding to an access policy, They have data material, they have attributes associated to it, and they have actions and operations associated with the attributes. So Can you open? Can you read? Can you write? Can you delete something? Depends on your access rights. If you're familiar with Linux or Unix, you have this all the time because this is what you set for files, for directories, for users. And then read, write, and execute are essentially your three access rights. And you set them for groups, you set them for directories, for files, for all sorts of different things. And it's really the same concept, actually. In fact, security itself hasn't changed in years since the beginning of people thinking about, oh, we should have security. I mean, we're still using all the same techniques. So we're using passwords, we're using authentication techniques, we're using encryption. So the algorithms change because every time you come up with a new encryption algorithm, you come up with a decryption. So you can decrypt the encryption. And you have to anyway because you have to figure out how to decrypt it to read it to authenticate. And there aren't that many alterations, and there's generator programs that can decrypt a lot of stuff. So what the secret now, in fact, it's not written on here, but this whole public key, private key, and digital signatures are a better mechanism for this type of encryption, because now what we can do is say, well, let's just not give you all of the information. So in the old days, we gave you the entire file, it was encrypted. So you ran an algorithm against it to decrypt it if you wanted to hack into it. Now, if you run the whole entire algorithm on it, and you decrypt the entire, you still don't have everything, because you're missing either a key or you're missing part of the data. So, because you don't have to actually send all of the data, you can have a piece of it. You can have it partitioned out into chunks. But most common is this public-private key, where you have to get something from a third-party authenticator who says, you're the right person. Okay, good. Here's our key. Here's our key. Here's your key. So it takes two keys to actually unlock the file in terms of the decryption instead of just one. It makes it a lot more difficult. In fact, right now, I think that's pretty much current. Two key, public key, private key, and digital signatures. Digitally signing something. In fact, you get programs like Adobe. I think even Microsoft Word does it these days to add a digital signature on the bottom. It's just a code essentially attached to the file that says this is where it originated from. This is where it came from. We see this with SS2 and some of the other technologies that are out there for the internet. For, let's say, for example, we're going to do credit card processing. We'll get a digital certificate. It's a code we put on the website that we send along with it. It goes out for third-party authentication through a certificate authenticator. It says, oh, yes, you are www.hacker.com. That's you. Okay, good. And so make sure you're the one who's actually processing the transaction. So, because what ends up happening is you get people that, impersonate different websites, impersonate different people, identity theft, essentially, on a business level. And they try to run transactions, and it's like, okay, that defeats the purpose. So let's send some encryption to it. And then, let's authenticate it somehow. So yeah, third-party authentication is not a bad idea in terms of the up-and-coming, the current techniques. If you're not using third-party authentication, or public-private keys in combinations, using the public keys, you're probably not strong enough encryption-wise. In fact, another concluding comment on encryption before I move on is that what you're trying to do is deter. It's like when you lock a door and you put a lock on it. You can put a big old lock on it. It's going to take longer. You have to assume that the lock's going to be broken. But how long is it going to take them to break the locks? And then once they open the door, is there going to be an alarm that goes off? Assuming that they're going to open the door eventually after they get through the 20 locks that you put on it. So how easy are you going to make it for them to actually break through it is really the point, with the assumption that they will break through it. So you have backup techniques. So if they open up that door, you have an alarm system that's going to call the police or something. Well, you do the same thing with your software. You make it so that if they actually get to the certain point, which they're going to get there eventually, you don't want to make it too easy. But once you make it reasonably hard for them to get there, then you put in system reports, logs, and things so that you can catch them. Here's the IP address where you came from. Here's what you did. Ooh. Which kind of goes back to the old networking utilities where system administrators would log user activities and then send out messages, alert messages. Hey, look, so-and-so's deleting something. Wait a minute, what's so-and-so doing? So if you have one of these types of systems and someone's broke, then nowadays you'd get an email message or you'd get a text message or something that says, network error, intruder, Then you press a button and it shuts the system down completely, just to lock them out. But that's essentially all you can really do. And in terms of security and people are insecure. We're humans. We make human error, but we're also careless, we're dishonest, and we're malicious. It's hard to believe, but true. Not all of us to the same degree, but you take any disgruntled employee. Actually, if you were a student here at IT and someone said, okay, you're not a student anymore, get out of here, you're going to be upset. If you're upset, if you have access to a computer system, if I were you, I'd go in there and destroy everything, or, I'd do whatever in retaliation, probably. Depends on how mature you are. How much you really liked being a student here, I guess, or whether or not you think you're going to get back. But people don't think about that stuff. So we have people that do malicious stuff. We have people that work as bank tellers in banks who steal customer numbers from customers that they're helping. We have customer service people who write down credit card numbers where they're taking over the phone. Actually, in the old days, this has been stopped, but people used to put carbon paper under the sales order, so they keep track of all of the information, and they go home at night and they go online and they go on a shopping spree with all the credit card information. They don't have to write it down, they just put a piece of carbon paper underneath it. So now that it's on the computer, they can't really put a carbon piece of paper underneath it, but little tricks like talking on a cell phone and then these are all things that have happened actually in the U.S. Bank tellers, now they don't allow cell phones. It's a security issue. If you're talking on a cell phone and you're reading off, customer's name, here's the account number, all on the phone, pretending like you're talking to a customer. Because what do? They read account numbers. What is your account number? Can you verify that? Was that 123 or was that 122? You can easily fake a conversation in which you're giving the information. And actually, the case that was kind of high profile I think it was at Bank of America, and the person she was giving the information to was in one of the other windows. She was in the back talking to someone who was at a window trying to make a withdrawal out of somebody's account. That wasn't neither one of their accounts. But unfortunately, people do that stuff. Long story short, dishonest in terms of stealing from financial systems. Denial of service attacks. I don't know why people do that, but they still do it. They try to send as many pings as possible to a server to take it down. So I don't think anyone's deliberately taken down the ITU EMS. I think it goes down on its own. But perhaps, maybe in the future, I don't know, we'll have denial of service attacks. I don't know. Usually people would just love to get in, I think, to get in to post something. I don't know, I'm a disgruntled employee right now because I can't get access to the EMS. Well, I can get access, I just can't update or look at anything. I don't have the right privileges. All right, so security goes as far as it messes with people's ability to actually do their job. So many security problems come from inside of the organization as well. So in large security organization, we have disgruntled and dishonest employees. Security relies upon trusting individuals. What if they are dishonest? Well, you can't really help a dishonest person. You can't really send them in the right direction. Instead, you can just watch out for it and assume you're going to find some of it somewhere eventually. And it's generally the people you would least expect, usually. So the design for security in terms of people, how do you prevent people-oriented issues? You can make it easy for responsible people to use the system and make it hard for dishonest or careless people to use the system in terms of password management. So this is why you always have to change your password, but it's only like 15 days or 7 days you have to change your password. You can't lose, but you have a password. Train people in responsible or ethical behavior. In fact, a lot of companies have ethics classes, believe it or not. This is kind of a new thing that's come out in the last couple of years. They have ethics training. It cuts down on problems. It sends employees to, this is wrong, and this is wrong, and that is wrong, and that is right. So people know what they're supposed to do. Because a lot of people, maybe have never been exposed to the concept of what happens if I have 50 cents extra. Do I put it in my pocket or do I put it in the cash register? Who belongs to this 50 cents that ended up on the counter, or $1 or whatever it happens to be? But if it happens 20 or 30 times during the day, it adds up. Or, I wasn't aware I wasn't supposed to drink and eat the food that I'm making or that I'm exposed to. And then do not hide violations as well, and then test the security system. So a lot of people like to cover up violations. They say, oh no, nobody ever steals from this company. And then everybody knows, yeah, so-and-so just stole this, and so-and-so just stole that. And it seems like you're lying to them, essentially. I didn't leave that slide up long enough for you to talk about it. That last slide that I just showed you a few minutes ago has an excellent URL for Trust in Cyberspace. It's actually from the Committee of Information Systems Trustworthy National Conference. Not too bad. It's about 10 years old, 1999. But believe it or not, nothing has really changed. We're dealing with the same issues that we still haven't fixed from about the last 10 years or so. But the link still works. The organization is still in existence. And it's pretty relevant in terms of some of the concepts. All right, that was the part that I forgot 2 weeks ago. Or I didn't forget, I just left out. Today's new, improved, better topic for the menu is predicting the resources required for a software development process. After we predict the resources, then we can actually put a cost value on them. So this it doesn't involve mirror balls or guesstimating or any other type of prediction or statistical analysis. This is following software engineering practices to predict what kind of resources are you going to need. Because the number one problem with most software engineering projects is being able to estimate out and to come up, not only to come up with a full set of requirements, but to estimate out the cost of this project so you can make a profit. Because you don't want to do it unless you're going to make a profit, essentially. But there are a lot of software engineers that make software for a living, and they never actually see anything from it. Because they end up using too many resources, spending too much money on it, and it turns out to be a disaster. So they probably, half the time it ends up getting scrapped. The other half the time it ends up becoming something that nobody's even using anymore. But the objective of this particular lecture is I'm going to introduce the fundamentals of software costing and pricing, as well as resource allocation. How are you supposed to put together these resources? Describe some metrics for software productivity assessments. I'm not going to go through software metrics. We covered those actually in Software Engineering 1, and if you missed all of that, you can look through the Software Engineering notes for Software Engineering 1. In fact, there's some pretty interesting metrics. Not all of them are being used. Function point, we'll talk about that one. Function point analysis, object point analysis, because that actually makes sense in terms of a management science to apply towards estimation and metrics, measuring the software. And then explain the difference between these techniques and how they should be used for software estimations. Resource allocation. And then I'm not going to get to the Cosimo model today. I'll talk about that next time. But because this is a pretty long, this is like a 60 or so lecture, 60 or so slides. If I make it halfway through, I'll be lucky. But we'll definitely finish this one, and we'll talk about the Cosimo model, the algorithm for it next time, actually. So what I want to talk about today is the productivity, estimation techniques, algorithm, cost measurement, or cost modeling, project duration, staffing, some of those issues that come out in terms of how do we estimate out what we need. So part of it's resources. If you think about the concept, the entire project is resources. Because we don't have any parts. It's not like a manufacturing facility where we have equipment. We have to buy special equipment to mold a part, or we have to go out and get a part molded. We don't have materials costs. That's easy to estimate. You say, what does it cost for the sheet metal? What does it cost for the screws or the wood? We can add up all the parts, and we can kind of figure out from a cost model what the product is going to cost to make, how long it will take to assemble, usually. Software is a totally different animal, but it needs to be attacked the same way. We have to figure out what the resources are that are going to add up to the cost. Everything's a resource. People are resources. Equipment's resources. Time is a resource. So if you narrow everything down to resources, all you have to do is pretty much add up all the resources. And you got the cost of the software. But unfortunately, nobody ever knows about this until it's all over with. Because they don't know exactly how many man hours it's going to take, exactly what kind of technology they're going to need, what components, what drivers, what algorithms, what interface pieces they're going to need, whether it's going to work in this language, whether I'm going to have to use that language over there, what methodology I'm going to use, usually until the project is over with. That's how the Cosmo model actually is kind of based. It takes and looks at previous projects as a model. And it says, let's learn from our mistakes. Let's take everything we used to do, map it all out. Because if you think about the concept, this is how people do manufacturing sometimes too. They put together a prototype after they've estimated out everything. And then they figure, what did the prototype cost? And they go, well, what is it? And then they see what the first run costs, and then they adjust the pricing. Because until you actually run it through the assembly line, until you actually have a finished product, you don't know if it's going to, well, you have proof of concept, hopefully, from a proof of concept type prototype, but you don't know exactly what's going to happen. And then you can kind of predict downtime, slack time, other problems in the scheduling. So that when the first batch comes out, you know, if I make 100 of them, it's going to cost me so much. And then you play with the numbers. You go, well, what if I make 200 of them? Does the cost per unit go down? 300. And then you find out the production mix that works best. How do you do that with software? So you have to follow different models. Cosmo kind of takes that concept, though, by building previous projects, uses it as a basis to estimate future projects. I'm going to talk about that one next week. That's the last one. But before we get there, let's say we're working on our first project. Some of the questions we're going to run into in terms of fundamental estimation questions is how much effort is required to complete the activity. So you read an ad on Craigslist. I said, can you write a driver to interface my USB port with my modem? You know, oh, okay. I have no idea what that means, but yeah, 2 weeks. You know, where did the 2 weeks come from? You know, you just guessed, essentially. And then you can start working on it, maybe it takes you a day and a half. Or maybe it takes you 3 weeks. So it's a trial and error kind of thing, which actually happens, believe it or not. In fact, anyone who can come out on an ambiguous estimate and give me 2 weeks, $5,000, tells me in 2 weeks they're going to need $5,000 for something and they're going to try and get it from me. They have no idea what I'm even asking them to do. They're just trying to get me locked in so I give them the money. Has nothing to do with my project, really. So how much calendar time is needed to complete the activity? How much total cost for the activity, including all of the extra expenses that the contract programmer never really thinks about? Like, oh, I need a license for that. Oh, I need that toolkit. Ooh, I don't have that compiler. Ooh, you know, software can actually kind of be expensive. The tools can be expensive. Project estimation and scheduling and interleaving management activities with that. So intertwining all of it together becomes a problem. So software cost components. We got hardware and software costs. This is the interesting thing. So you're building software. They say we need software. You're building the software interface that fits on that chip that's going to make that little robot work. And then you discover, well, in order for my software to work, I'm going to need an input device, hardware. So although you're building software, if it's just a software project, you can't forget about the hardware and vice versa. Because if you're building hardware, where am I going to store the program? I need some memory. How much memory do I need? What kind of memory do I need to put on my hardware to support the software interface that I'm going to use? It works both ways, but because this is a software engineering course, we're going to focus on the software component part of it. They both have the same challenges, actually. So sometimes you find you have the software, but you don't have the mouse. You don't have the laser. You don't have the inputs. Where are you getting the signal from? This thing needs an internet connection. Oh, you know, doesn't exist. So that would be part of the cost components, travel and training costs. To actually, you know, are you going to do it all yourself? Are you going to have a crew? If you have a crew, and the program must be written in XYZ language, nobody on the team has ever heard of XYZ language, then how long is it going to take to get your team trained on XYZ language? And maybe you shouldn't take on this project because it's going to take you too long. And your training costs are going to be too high because the classes for XYZ are $10,000 a shot. and they take 2 months to learn XYZ, and nobody in the company knows XYZ. Bad idea. Costs too much. So you're probably not going to take on that project anyway. Traveling costs. Actually, believe it or not, that might actually be an issue that people don't think about. You know, oh, it's in Sunnyvale. Where's the company? Utah or Colorado. How often do they want me to go there? Every day. You know, oh, I have to relocate. The relocation cost might be too much right there. Effort costs. The dominant factor in most projects. Effort. Salaries for engineers involved in the project. Social and insurance costs. Social Security, taxes, all the overhead expenses of having employees. Given you're running a software engineering company and you're not a solo programmer, if you're a solo programmer and you're running as a software engineering company, you still have the same problems, but they're all yourself. So you might think to yourself, well, I just won't get paid for the first 2 weeks. That's good for you, but anyone you're hiring isn't going to work. They're not getting paid for 2 weeks. So you have that to factor in. Effort costs must take overhead into account as well. Cost of the building, heating, lighting. Believe it or not, the cost to heat the building that the programmers are working in adds to the cost of the software. It should. Why? In any other product it does. You know, the retail firm that you got where you hired a salesperson to sell the product, their salary's coming out of the sale of that product, hopefully. So the cost of the networking and the communications, how much bandwidth are you going to need, how many new DSL routers or whatever you're going to have to put in to support. And you have to think about the concept. It's just not the creation, but what about the testing of this particular product? And I can tell you a real-life experience on that one. I was working on a project that was developing something that used an internet connection, and we were testing it on one type of connection. And then we realized, oh, we should test it on a higher speed cable modem connection. And we should test it on this type of a connection. What about wireless? What if someone hooks up a wireless router to it? We ended up having to go out and buy and install a ton of high-speed internet access utilities, connections. We had to go out and get Comcast and SBC GlobalNet and compare that against some of the wireless stuff and antenna stuff and all this equipment, which cost a bundle, just so we could test this product with it, because we didn't want to give them the product without knowing that it didn't work on anything. This was back in the dial-up days, actually. Knowing that it didn't work with anything that wasn't dial-up, you know, and it also supported dial-up at the same time. So that was a nightmare because all that hidden expenses in the communication overhead, and that was just for testing. I guess we could have not tested it. That would have eliminated some of those costs, but then again, we probably wouldn't have delivered a good product because we did find some errors. Also, costs with shared facilities, libraries, staff restaurants. You know, depending upon how big your company is. If you've got a restaurant that you're feeding these people, you know, taking them out for pizza at the end of the attendance, whatever, for the UTAs that went to the, it wasn't pizza, it was actually really good food. Dave & Buster's, I don't know if anyone went to that. So. All right, costing and pricing. So estimates are made to discover the cost to the developer of producing the software. And so there's no simple relationship between the development cost and the price charged to the customer. So we can't use pricing models like take everything and times it by 3 for 3 times markup, because it doesn't always work because we have other considerations to take into account, such as competition, the value, what the customer is willing to pay for it. So the environment is not quite as flexible as the consumer market. Broader organizations, economic, political, business considerations influence the price that's being charged. Also, people have this tendency to, you know, lowball a price to get a contract, and then they figure, well, later on we'll just boost up the cost, we'll boost up the price a little bit because of all these things we didn't take into account. And then they realize, oh, that's not right. That's not going to work. So let me make this a little bigger so you can see what this is. There's these software pricing factors with descriptions. We have some different factors that apply towards software engineering that don't apply towards other products. As an example, market opportunity. So the development organization may quote a low price because it wishes to move into a new segment of the software market. They have never built a scanner, but they'll build one just so they can get into the market, get their name out there, get known. Accepting a low profit on the project may give them an opportunity for more larger profits in the future, and maybe some experience. In fact, I used to know a couple of different programmers that took that on. They would work contract jobs, being extremely inexperienced, just learned Java for dummies in a weekend. They got their jobs. I don't know how they got hired, but it was not a bad way of learning. That job's working in building software so that they can learn more on the job, taking salaries that no experienced Java developer would accept. Something like $5, $4, something ridiculously low, so they could work on the project, so that they could practice their programming skills. Not a bad idea, actually. A lot of people do this, especially actors. When you go to Hollywood, people volunteer their time to work on the set. They clean the floors and the bathrooms, and they get coffee for everybody because they're going to be in the environment. They can watch what's going on. They can learn. So it's to their advantage. But they pretty much work for free, kind of thing. This actually used to be how TAs used to work in the past. Where are my TAs? You're supposed to work for free and help the instructor, because most of the TAs in a traditional environment, they wanted to become teachers themselves. So they were trying to learn. So they got to practice. So when the teacher was sick, they got to give the lecture, or they get to grade. They get to prepare the exams. They get to grade the assignment. So they could learn hands-on what they were supposed to do. And then eventually they became a teacher. But that's a different model than working here now. It's a full-time career for some of these people here who are working as TAs. But, that's just one example of a traditional university environment. And actually, in that case, the TA would be giving you the lecture right now, because in a traditional environment, I wouldn't have to do this at all. All right, so cost estimate uncertainty also exists as a factor. So if the organization is unsure about the cost estimate, it might increase the price with some contingency over and above the normal profit. So, in fact, a lot of people do this, actually. They say, well, if we deliver it before this particular date, then it's worth more. Then, because they've saved some cost on it, because it wasn't as difficult as they thought. So, either they get a bonus or the price gets reduced or something happens. So contingencies with, delivery dates, maybe some contingencies with features, with extra stuff added to it. It's like a negotiation. We have contractual terms. So a customer is willing to allow the developer to retain ownership, let's say, of the source code in return for reduced costs, so that the company can actually reuse it for other projects in the future. So the price charged might be less than if the software was actually handed over to the customer. Where else can you do that with a product? I'll buy this from you because I need you to make it, but you can keep the license to it. I just want to use it. This happens a lot with open source utilities. Actually, a lot of people get paid to make open source features on MySQL and on some other programs. Improve it, add it, fix a bug. Someone pays them to do it. They don't own it. They just want to use it. They just want to, they're using it with their application and it has this problem. So fix it for me. I'll pay you a little bit. And then, okay, good, but you still own it. Actually, nobody owns it if it's open source. But people do it all the time, actually, for encoding, encryption, all sorts of different things that, they just want it. So they'll pay for someone to do it, even though they don't own it. Requirements, vitality. So what if the requirements change? So might lower the price to win a contract. After the contract is awarded, higher prices may be charged for changing requirements. This is a loophole that programmers love and customers hate. Because programmers go and say, well, this is, okay, what do you want me to build? And the customer says, oh, I want you to build this, this, and this. And the guy taking the information knows it's not going to be that easy. But he'll write up the requirements, and then all of a sudden, after the contract's signed and they agree to a price, the guy will come back and say, well, if you're going to do this, you're also going to need a database connectivity as well. Wouldn't you like a database connectivity for this? Oh, I didn't think about that. Oh, I can add it to you, but it's going to cost you another something, So you add to the price. Oh, yeah, don't you want this on the internet, too? Don't you want this to be web accessible? Oh, yeah, don't worry about it. We can do it for you. It's just going to cost you a little bit more, All of a sudden, it's just like stuff keeps adding up to it. It's like when you buy a car and, oh no, that's the base price. You want a steering wheel? All right, actually, no, it's included. You want power steering? I don't know. You want automatic transmission? Oh, wait a minute. You know, you add to the price. And so the price turns into like $20,000 more than you expected. But you got what you wanted. So, but it started out really cheap. It started out affordable. So it happens with a lot of products, especially software. Maybe financial health, developers in financial difficulty. That's what I said about that $5,000. Oh yeah, I'll take it off of Craigslist. And they may lower their price to gain the contract. It's better for a small profit or break even than go out of business. Or, you know, who knows, maybe lightning might strike the contractor and he might figure out what you were asking for, and he might actually deliver the product or learn the language or whatever it is he was supposed to do. You see a lot of building contractors playing that game. Oh yeah, I can put an awning in for you. 5,000? Sure, 5,000. Here, give me a deposit. And 2 weeks later, it's like, I have no idea how to build an awning. I'm supposed to build an awning. And then they learn how to do it, and they actually do it sometimes. So, depends on what you're doing. Programmer productivity. Here's another interesting thing that happens. Not everybody, it's not like a machine. You have an on and off switch. And every 200 rounds, the thing needs an oil change, or the thing needs the arms lubricated, or the battery changed, or it's kind of like running a camera or a piece of equipment. Programmers don't run that way, so some of them work slower than other. So, and junior, senior level ones, different skill sets. The measure of the rate at which the individual engineer involved in the software development project produces the software and associated documentation as well. You might have some that are good at writing software that don't do any documentation at all. Not quality oriented, although quality assurance is a factor in the productivity assessment, but it's not necessarily quality oriented. Because nothing is ever written without bugs. And it really doesn't matter how skilled the software developer is. Something that is prone to more bugs is going to have more bugs. Something that's more complicated is going to take more effort, regardless of who's writing it. So essentially, you want to measure the useful functionality produced per time unit. And so you have productivity measures, and this is where you try to use the metrics. This is where this information comes in. So you have the size that's related to the measurement that's based on the output from the software process. This may be lines of code, hopefully not, object code instructions. You try to measure what someone has produced, and then you put a dollar value on, well, if you have to write 10 more lines, it's going to take this much more time. This is what the cost should be. Or we have function-related measurements, which is a little bit more accurate. It's based on estimates for functionality that's delivered, function points. So this is what I talked about in Software Engineering 1, was the function point analysis. Once you take the program, you break it out into function points. You consider internal, external inputs and outputs. You talk about, or you look at and you measure the complexity of each one of the code units, and then you put an estimate on it based on previous projects. How long will it take for this module, this module, this module, this module? You add it all together, and you get the total time it's going to take for a programmer effort, this generic programmer. So in doing that, we have some measuring problems. Estimating the size of the measure. You're measuring it in hours, half hours, the units, the size, days. Estimating the total number of programmer months which have elapsed. Did they have vacation time in there? Are they only working 5 hours a day on this? Are they not dedicating? Because that's the other trick that a lot of contract programmers do. They take on multiple contracts, and then they have them both, and they're getting paid on everything simultaneously, but they're not working on everything simultaneously. They finish one job, and then they have another job, and then they have another job. Some of them actually can multitask, go back and forth. But anyone said, oh, I'll save that for the weekend. I'll save that for next Tuesday. So just because you told them that you needed it doesn't necessarily mean they're going to deliver it with how long it actually takes them to do it, so that you have that slack time in there. Estimating the productivity of the contractor, the documentation team, incorporating this estimate into the total estimate. I'm going to skip through this extremely fast because it's not used anymore. You can't count lines of code, but people actually did this. So this is up for historical reasons. In old procedural languages, you could actually count the lines of code and figure out how much it was supposed to cost you. But now we have object-oriented programming. We have other techniques that don't lend themselves to lines. So what's a line of code, and what programs should be counted as part of the system? And assuming a linear relationship between the system size and the volume of documentation as well. And, issues with that. So productivity comparisons are probably pretty accurate. Lines of code not accurate. Comparisons are lower level languages. The more productive the programmer, the same functionality takes more code to implement at a lower level than a higher level. So in terms of the comparison, it shouldn't take you as long to build an object-oriented program as it does to build an empirical language one, or C++, a C language, procedural, or a imperative kind of language, because the objects are easier to create, fewer lines. Functionality is a higher functionality, higher level language. The more verbose the programmer, the higher the productivity, if you think about it that way, because they have writing more lines of code, especially if they're doing a comparison. So what you normally do is you kind of come out with an estimate per the language and not for the programming effort in general, because you can't do a comparison. Here's the high, low level languages compared. Analysis, design, coding, validation, Higher level languages take less time, long story short. If you ask someone to do it in assembly language, it's going to take them more time. More complex of a language. In terms of the system development times, we're looking at the differences between a high-level language, assembly code, high-level in terms of size. In terms of analysis, design is about the same. Where we get the size of the code, the effort required, and the productivity, you see the high-level language actually has higher productivity to it, which leads you to believe, and these are just old, this is just kind of a sample case, just doing a comparison for you. It is supposed to give you the impression that you want to pick the highest level possible, if possible, which is like why people like Java for programming projects. There's a lot of Java developers out there, and it's a pretty high level language, and it's pretty easy to learn. You can write a lot of functional code real quickly, and with little development effort, essentially. If you take and write into C these days, it's going to take you a lot more effort. It's a lower level. And usually I get someone who complains and says, wait a minute, C is just as hard, or Java is just as hard as C. It's the same language. Well, not really, actually. I would say C++ if you're programming in object orientation. But if you are under the impression, like I am, that C++ I think is a lot more difficult to program in, especially the .NET, more difficult to program in than the Java environment. Believe it or not, actually .NET programmers sometimes get paid more because of that reason alone. If you're going to spend all the time and energy to learn the .NET platform and become proficient, if it's C++ or Object-C or any one of the .NET Visual Studio application development environments, I mean, even something as small as ASP or something, just because it's more difficult, you're probably going to end up demanding a higher salary than a Java programmer. But there's more Java programming jobs because the people who are hiring you think that Java is easier. So they're looking for a cheap way out. A language that's more compatible, is cross-platform compatible. .NET's not cross-platform compatible, it's limited. So depending upon the project, if you go a different route, you're going to cost it out differently. If you're under the impression or if you're making assumptions that one language might be more difficult in comparison to another language, it might take more programming effort or something, you're going to use that in your cost estimate. So how do we accurately define how much it's going to cost to build something? This is one of my favorite function point analysis. It's been around for years. It's changed over the years. Now it's object analysis as well. It's based on a combination of the program. The characteristics look at external and internal outputs and inputs. User interactions, external interfaces, files used by the system, or database connections. So the weight is associated with each one of these. You figure out how many function points there are. You add up the function points, you put a time estimate on that. Some programs just have more function points than other ones. They're going to be more complex, regardless of the language that you're going to create them in. So you look at it instead of a programming language selection, you're looking at it in terms of the concept of what it is you're writing. What does the source code contain? But you don't know until you write it, but you do know what it's going to interface with, and hopefully you have some design ideas in mind for it. So the function points count up and compute or multiply each raw count of the weight and then add them all together, and you have a score. So function points count modified by complexity of the project. So more complex projects have a higher function point count than lower, hopefully. Function points can be used to estimate lines of code depending upon the average number of lines of code per language themselves, or per function point for each one of the languages. So if you wanted to combine this with a line of code analysis, you can take and say, well, this particular function point area, this category, lends itself or equals 100 lines of code. And we have 5 of these, so that's 500 lines. And you can go, well, okay. And if I'm looking at the size and the complexity, I might be able to estimate that out. And hopefully at this point you're getting the impression this is all a game. This is all, it's almost like flipping a coin, but we're using a science for it. We're trying to figure out ahead of time something we don't really know yet that we're trying to estimate. And the programming effort is probably the most difficult part to actually estimate out. So function points can be very subjective, and they depend on the estimator. How are you going to break something out? What are you calling a function point? How did you put 500 on that, or 50 on that, or how did you calculate that? So automatic function point counting is also impossible. You can't run this through. It would be nice to have a program you ran it through. Actually, it would be nice, in fact, maybe one of you will invent this, to take a requirement spec that's done in a particular, it has to be done in a particular format that's pre-designed. Run it through some program that is going to calculate out how long it will take to write the source code for this program in a given language. And then you can hire 5 programmers, have each one of them do it, and then take the average maybe of all of them, and then you'd actually get an accurate, I think you'd actually get an accurate reading out of that. In fact, that's what a lot of people do actually. They hire multiple groups to work on it simultaneously, and they figure out an average. How long did it really take? And sometimes they pick the best one, pick the best version out of all of them to use, actually, which kind of seems ridiculous. But if you have people laying around, or and it's only a 2-week project, you could probably afford to experiment that way a little bit. Because the better you are with your estimating, the more profitability or more profit you're going to make out of your business. Because spend a little time now, learn how productive your people are, what you guys can accomplish, and then you know what you can charge in the future and how to actually estimate out the work. Object points are just like function points, but it's used with object-oriented languages because everything's object-oriented these days. So the alternative, so you're measuring in 4th-generation languages, similar languages, you're using it to measure the function points instead of functions. And when I say functions, it's modules, procedures, functions, objects, they're all the same. They all fall into the same category. Objects are not the same as object classes. The number of object points in the program is the weight estimate of the number of separate screens that are displayed, let's say, the number of reports that are produced, the number of 3rd-generation modules that might be developed as well, supplemented to the 4th-generation code. So in terms of the point estimates, the object points are easier to estimate from the specification than the function points because they're easier to see, actually, in the design. And they are simply created with screens, reports, and 3rd-generation modules. So some people actually kind of take, and they'll take like Visual Basic as an example, put together all the components so that they can count them. They go, well, we need a controller for this. Here it is. We need a controller for that. It's like a modeling language, essentially. In fact, some of the modeling tools allow you, some of the UML modeling tools allow you to do object point estimations because you have all that stuff in the design. Why not calculate it right there? How long is it going to take to build this thing? How long should it take to build this thing? Given the parameters, how many hours and how many lines of code or how many modules per hour does somebody build on average? So there can be an estimate at an earlier point in the development process, especially if you're doing it in the design phase. When you're putting together the UML model, you're doing something, then you've got some estimate right there. At that stage, it's very difficult to estimate the number of lines of code in the system because you don't have the program built yet. You haven't even started. Because normally what ends up happening is you start building it. And then you're building, wow, this took 2 weeks. Wow, okay. Wow, look at all the code that was produced out of this one. Uh-oh, a little bit more difficult than we expected. Or you get the exact opposite. You know, oh, we're done with it already. Okay, well, let's fit that. And then that's when the project manager needs to come in, reorganize the staff a little bit, have people change the orders of stuff so that more stuff can get done in a faster amount of time because you have Slack in there. So, in terms of the productivity estimates, the real-time embedded systems, these are old numbers. 40 to 160 lines of code per month. I don't know if that's really real. You can't rely upon these stats. Systems programs have an estimate. There's books out there that give you productivity estimates. And I want to know what robot programmer gave you all this information that you documented. Because everybody works a little differently. You know, some people, you know, work more productive at night, more productive in the morning. What hour did you test them? You know, did you test them on a Monday morning, or was it a Friday afternoon as well? Or was it the weekend? And who did you get to do the testing? Because unlike other professions, engineering, programming is not measured the same way. It's like experiences in the eye of the beholder. You may have taken a class, you may have written so many programs, but it depends on the problem scenario and the code that you're writing as to how much experience you really have had with it. You know, have you been writing all a bunch of drivers? Oh, now I have a web development project. Oh, it can be a totally different animal than writing a driver, a low-level driver. Or, you know, the scenario might be totally different, and which reduces your productivity right there because you're not familiar. You know, your scale went from senior to middle to junior level if you're running on a scale. So factors affecting productivity. Here's some formal stuff. I kind of gave you a few of them a few minutes ago. Monday versus Friday. And believe it or not, that does affect productivity. Why not? It affects it in any other job. Salespeople are a lot more gung-ho on a Friday than they are on a Monday, which means you want to do your shopping on Friday. You get in and out of the store fast because the person just wants to go home. Monday, they're there all day. Now they're there until the rest of the week, so they're going to be slow. Application domain experience. I just kind of described it a few minutes ago with a driver versus a web program. Knowledge of an application domain is essential for the effective development. Engineers who already understand the domain are likely to be most productive than those who are brand new. I've got 25 years of experience writing web programs. I've never written a driver for this particular mouse or something that you're looking at. See, so it doesn't matter. Programming skill doesn't have anything to do with it. Process quality. The development process used can be may have a significant effect on the productivity. You can't see Chapter 31. If you do, it's out of Systems. No. Software Engineering, a Practical Approach. This is the name of the book that this came out of. And it's out in print by Roger Pressman, who's got about 8 or 9 different versions of this book out. It's like the most used book in software engineering. You can get it for $3 or $4 on Amazon used. So Software Engineering, a practical approach. It might be a practitioner's approach or a practical approach. I can't remember the exact name, but it's by Roger Pressman. You put in Pressman. Oh, you got the book right there. Or did I give you that book?
No.
That's your book? I have that book. That's the Pressman book. Yeah. What's the title of that book?
Software Engineering,
a practitioner's approach. Okay, good. That's where this information is coming from, actually. So you have one of the earlier versions of it too. You have one of the current versions.
6th edition.
Yeah. You just bought that book out of? Or is that from Software Engineering One? $5 on Amazon. So we got proof right here. I'm not lying. So it's a good book, actually. Yeah, it's like a reference book for a lot of engineers because it has everything in there. So anyway, going back to the process quality, the development process, it's almost like anything. You know, if you're organized, if you are tracking everything correctly, if the person's not standing around waiting for so-and-so to arrive who has the key to something that you need to open up the file cabinet to get the source code file out or something, I don't know. It depends on availability. All these factors play into productivity. Project size. So the larger project, obviously the more time required for the team to communicate. Less time is available for the development of the individual productivity. In fact, the more meetings you have. I really love the business people who like to communicate with the programmers. It's like a personality clash to begin with, and then it's how many programmers like to spend hours on end in a meeting listening to business people talk about the project. Not really, it doesn't really help your productivity at all. In fact, if anything, you just want to go home at that point. You don't want to go back to your office and write more code, although it might be a nice break. But it doesn't put yourself normally in the kind of frame of mind you need to in order to be productive, especially if you're trying to fix a problem, solve a problem, someone's taking you away from it. So, technology support. So, good support such as case tools, development environments. That's why people like development studios. They like platforms. They like groupware tools for developers with source code check-in and check-out, some version control. The quality of the development environment, believe it or not, leads to the overall quality. Higher quality in the software, less time it takes to actually write it, more productive the team can be. Because the last thing you really want to do is actually go through and say, what is the most current version of this? I thought I gave it to you. I didn't give it to you? Here, let me give you another one. And then you spend all day testing something to see, I thought we fixed that bug. Oh, no, we didn't fix the bug. Oh, yeah, we did. You're just using the wrong file. And miscommunication going back all because you emailed source code files back and forth and someone has the wrong version of something and something went wrong. So the working environment as well, quiet environment, well, it actually depends on the person as to what kind of environment they want, whether they want a quiet one, whether they want a loud one. So in terms of quality and productivity, actually they work hand in hand. So we have, I'm keeping an eye here, we're good. So we have metrics that are based on volume and units of time, Claude, because you do not take quality into account when you're looking at particular volume and units of time, which is why you can't count lines of code. It might be really bad lines of code. So you want to make sure when you're measuring this, you're keeping quality in as a factor. So productivity may generally be increased at a cost of quality. Oh yeah, we wrote this over the weekend. Yeah, the guy stayed up all weekend long, lived off of coffee, and by the time Sunday came around, who knows what he was writing, who knows what happened with this, but he got it all done. It's kind of like when you write a research paper and you write it all in one day, or you do all the assignments for this class the week before the end of the term, and then you decide you can't even upload them because everybody else is doing the same thing. Productivity goes downhill, so does quality. So it is not clear how productivity and quality metrics are related, actually. It's hard to test quality. It's hard to measure how much quality you're getting. And if change is constant, then the approach based on counting lines of code is not meaningful as well. Things are changing. So, estimation techniques. There's no simple way to make an accurate estimate on the effort required to develop a software system. So it's an art and a science because there is no exact science. And if someone tells you there is a science, then maybe they have a new invention that I haven't heard about. But there is no way of actually doing it. Initial estimates are based on inadequate information, generally by the user requirements definition. Because the user's requirements documentation, that user spec you come up with, sometimes changes. Sometimes it stays the same for the entire life of the project. Sometimes it changes. And that might actually be an inaccurate measurement if you're using that for your metrics. Software may also run on unfamiliar computers, use new technology. The technology might be broken. Platform might be broken. Operating system might be incompatible. So many other little things that can pop up. People in the project may be unknown. They may also not be familiar with the project. So you have startup costs in terms of somebody getting on board, getting familiar. Especially if you have a lack of documentation, which is very common. Nobody likes to document anything. Why? Is it leading to your productivity? If the person who's hiring you is not counting your documentation code or any of the work product that you're producing outside of the source code, then it's not leading to your productivity score. And so usually you're going to leave that for last. Get the code written first, which means somebody new who comes on to work with you is going to have a longer startup time. Project cost estimates may also be self-fulfilling. So the estimate defines the budget, and the project is adjusted to meet the budget. So the manager says, oh yeah, here's the budget, and we have 2 people. So you guys are going to build all this code in 2 weeks. Okay. Right. And so it's unrealistic, or it's because, we have to get it all done for a certain time. All right, this is actually the stopping point before we start talking about the estimating, the calculations for Cosimo and some of the other models. And in this next part, we're looking at estimating techniques for algorithmic modeling, cost modeling, expert judgment kind of techniques, estimating for all sorts of different kinds of popular approaches. But just keep in mind that none of these approaches are foolproof, and this is not an exact science. These are just popular approaches that people have used. So this is an excellent, although we're gonna end up being about 15 minutes early. This is an excellent stopping point, though. So now I can remember for the next lecture where I have stopped. Slide 23, so that the next time I can start up again. And stay tuned for information about where, if you just came in late, I have to repeat this. If you just came in late, I announced at the beginning of the class that there's a possibility that we might actually be at the new building next week, but we don't know for sure. It's kind of, they're behind schedule. They didn't estimate out their time correctly on how long it would take for the move. They're still holding to the 28th, which is Monday, and which means next week we would be here. However, you're going to find out, because you're on Wednesday, no big deal, because you'll find out by Monday where the students are going. I'm hoping that they're going to send out an email message maybe. If you have problems, you don't know where to go next week, send me an email message. I can probably answer the question for you. Don't send it to me till after the weekend, though, because I don't even know. As far as I know, we're at the new building next week. So, and if you have any questions, you can let me know. Okay, good. We're done for today.